Hi everybody, this is Dave Robertson from the USDA Agricultural Research Service. I'm located here in Adams, Oregon. We're also known as the Columbia Plateau Conservation Research Center. And I wanted to talk to you today about a winter wheat residue management study that we're beginning. We don't currently have any results, but I wanted to summarize the details of the study and what we hope to obtain in terms of measurements and outcomes. We're going to be looking at 4 different treatments for residue management strategies. The first of these is a high standing stubble. Stubble height will be maximized at harvest, and that stand will be left through the chemical fallow year until seeding. Secondly, we'll have a high cut followed by swathing and baling. Of course, this is a much more common practice these days with the price of straw bales supporting it. We'll be looking at a high standing stubble that'll be flailed in spring after any potential snow catch has occurred, and that'll be left in place hopefully as an even, well-sized cover. And then finally we'll do a low cut at harvest and just spread the chaff with a combine. So we're going to be conducting this research at 2 different sites. We want to look at the effectiveness of the experiment in both the low precipitation zone and the intermediate precipitation zone. The intermediate site is located in the Blue Mountain foothills near Adams, Oregon. Receives probably 18 inches of rainfall due to the upslope into the Blue Mountains accentuating precipitation there. It's in Athena silt loam soils, and I'd like to thank the Confederated Tribes of the Umatilla Indian Reservation for leasing us the land. The second site is in the low precipitation zone and receives probably 9 to 10 inches a year, so quite a dry site. It's in Warden silt loam soil, and it's near Lexington and was provided to us by Chris Rausch from Starvation Farms. And again, we're highly appreciative of him helping us out and finding some good land to do research on. So what factors or parameters might lead to a strategy being successful? In the case of temperature, obviously you want to reduce temperature, which will lead to evaporation losses being reduced as well. Common wisdom is that tall residues shade soil surface and should reduce temperatures. We anticipate that this is going to vary from site to site and year to year. Better stands and taller stands obviously will be more effective. We're going to be measuring temperature using an Atmos 22, which is a combined wind speed and temperature sensor that I'll discuss a little more later. So much like temperature, wind and wind speed is very important in terms of enhancing evaporation. So if you can reduce wind, you can reduce evaporative losses. Tall stubble is thought to reduce wind. A study done by Lauren Port at Washington State University as part of a master's thesis looked at triticale stubble that had been harvested with a stripper header, and it was found to reduce wind speed to less than half of a reduced tillage fallow. Wind regimes at both sites are expected to be quite different at times. The dry site is in the lower basin, where you have pretty effective west winds and a pretty high average wind speed. So high evaporative losses. There's a reason they put wind towers out there. The higher rainfall site will have downsloping winds at times off of the Blue Mountains, which can warm things, and it can be quite different. And there are times, even though it's only 2 miles from here at the research station, that it'll have temperatures that are 10 to 15 degrees warmer here due to that. So both sites will be quite different. We'll also be measuring this with the ultrasonic wind and temperature sensor that I'll discuss later. Those will be installed in in-row spaces at about a 6-inch height. Albedo is the ability of a surface to reflect solar radiation. Black body would be low, like a 0%, and freshly fallen snow would be near 100%. In our situation, snow is going to reflect more than stubble, and stubble is going to reflect more than most of the soils in our area. Should be highly variable depending on your mix of stubble and soil that's exposed. And of course, that'll be trumped by any snow that's fallen on it, frost. It's likely will change through the season. So it's not something we're going to measure directly, but it should bear out in terms of near surface temperatures that we measure. Snow catch is also very important. It's pretty much acknowledged that taller residue leads to greater snow catch. Dr. Haiying Tao at Washington State University looked at stripper header stubble and found that it decreased drifting and increased soil water. Do we get enough snow to make that important in decision making? We'll look at the sites for the time that we're there and try to draw some conclusions. But the reality is that it may be variable enough from year to year that what we find might not bear out over the long term. Where's the snow catch going? There's a question of sublimation versus melt, and that's going to vary from event to event. We may measure this with somebody going out there and physically measuring it, or we may try to also install a camera or two to look at possibly a graduated stick, like a meter stick, and get regular images to look at the progression of the melt through each snowfall event. So I've included these 3 photos to kind of bear on the complexity of trying to understand how this all works together. This is from 2 winters ago. We had quite a bit of snow. Actually, the most I've seen on the ground here, which was about 14 inches. Stubble was completely covered, started to melt, and you can see the stubble poking through. And this next slide here shows the accentuation of melt and possibly sublimation, where the water goes directly to the atmosphere. And it's hard to know which is occurring here, or at least in what proportions. Temperatures were pretty low still. I don't think it got much above 40. It took several days for this to melt off. But you can see it really does have an impact on how quickly things are either melting or sublimating. This is about 2 days later. And again, you can see it's really melted off in the areas where you have stubble. So it probably accentuated catch, at least up to the point until things were completely covered. But it definitely sped up melt as well. And I would imagine in some years, you might keep more by getting it in the ground quicker, as opposed to having it on the surface in the areas with less stubble. And perhaps that's more prone to sublimation. Some of our hydrology sites we've seen where we've had several inches of snow thought it was going to occur as a runoff event, and instead the wind pretty much essentially carried it away. So it's pretty complex, and from event to event it's hard to know how that's going to bear out. We're going to be looking at row direction at both sites. The experiment will be replicated in a north-south and an east-west direction. Thinking is that this may enhance some of the factors that I've talked about previously. May better intercept sunlight, may better intercept wind speed based on whatever the predominant wind direction is, and perhaps have some effects on snow catch as well. Cover and insulation is incredibly important. while tall residue provides shading and wind protection. If you look between the rows, there's really not much cover on the soil surface. Probably as the residue breaks down, which actually is inhibited in tall standing stubble, this may provide more cover. It's hard to know what the difference will be through time as that breaks down. It's expected that flailed residue cover and possibly the low-cut chaff will both provide, if they're even and thick, will provide a very good cover and keep moisture from returning to the atmosphere. Dr. Stuart Wiest, who's currently our research leader, has looked at this quite extensively. He recently found that you can see in the following slide, relationship that's proportional between residue thickness and density and the amount of precipitation preserved. These are the results of Dr. Wiest's lysimeter work. You can see the varying residue covers on the right. Units are pounds per acre. And in the chart you can see through time across the season the preservation of precipitation events and the cumulative effect based on the amount of residue cover, again in pounds per acre. And obviously it's significant and bears out at having a thicker residue cover. So in the image on the right, you can see our test bed for the Atmos 22 wind and temperature sensors. We're putting out 32 of these at a time, looking for intersensor variability, see how they perform in the stubble. Unlike anemometers that you might be used to with cups, 3 cups that spin, these are ultrasonic, so you can pick up lower wind speeds. There's no threshold to get the cups moving. And they also have a thermistor where the air flows through that's covered, so it's a shielded temperature, which is what we want. And those will be placed in between rows in each of the treatments, and one per plot. We're also going to be looking at humidity in the near surface environment. This is a MX2301 from Onset. It's a hobo. These will be placed in solar radiation shields, and they'll be at a coincident height with the Atmos 22s, which will be about 6 inches or 15 centimeters. So this will also do temperature, so we'll have paired temperature and humidity. And of course, what you really want to know is how much soil water you've preserved through the season. Bottom line will be how much soil water we collect with soil samples. We'll be sampling right after harvest and then after the chemical fallow season to see how much each treatment preserved. So I'd like to acknowledge several of our partners. Oregon State University, while not directly involved in this project, is involved in several projects on the site and has helped me with this project at times. It's much appreciated. As I said before, Chris Roush from Starvation Farms and the Confederated Tribes of the Umatilla Indian Reservation. I want to thank them for providing us research sites. And I want to acknowledge some of the work being done by others. Bill Schillinger has worked with Stuart Wiest and on his own extensively looking at these kinds of questions. He's currently looking at some different residue treatments with a producer named Derek Schaefer up near Ritzville. Very important work. And as I stated previously, Washington State University, some of the others that have also been involved in this kind of research, we're looking at what they've done and building upon it and around it, and I appreciate the hard work they do. So anyway, I hope everybody's healthy, and thank you for listening to me, and have a good day, and hopefully we'll see you at Field Day next year in person. Thanks a lot.